Hello students, today we'll talk about the solution of the same example, previous example, by using flexibility method. To review the example, we have two spans beam loaded with uniform distributed load and support are hinge at joint 1, roller at joint 2 and joint 3. From previous lecture, we find what is the indeterminacy for this structure. It is indeterminate to the first degree. So first we have to make this structure determinate, then we can solve the structure. Because it's indeterminate to the first degree, we have to remove one reaction to change this structure from indeterminate to the first degree to determinate. So you have to remove a reaction at joint 1 or joint 2 or joint 3 to make this determinate. So in this example, we remove joint or reaction at joint 2. So this beam will be simply supported beam subjected to uniform distributed load, and the deflection at joint 2 equals delta. Now, the idea of flexibility method, we have to use load, concentrated load P at the same of the removed reaction. This force prevent this beam to deform at joint 2. Or in different words, deflection under concentrated load equals the deflection under uniform distributed load. So at the end, this deflection from uniform distributed load plus the deflection from concentrated load equals 0, because this structure actually doesn't deform at joint 2 because it's supported at this joint. So delta under uniform distributed load minus delta under concentrated load equals 0. By using table 1, we use these two structures. Uniform distributed load, the deflection at midspan at x equals L over 2 equals negative 5 over 384 WL to 4th EI. It is negative because the deflection is downward. And we'll use deformation under concentrated load at midspan at x equals L over 2 PL cubed over 48 EI. In this case, it is positive because the deformation is upward. And the length in these two structures, L equals 1L. The length of the member is 1L. In the given example, the length is 2L. So deformation under uniform distributed load, first convert from L to 2L, substitute 2L instead of L in both equations. Then find the relation between P and W. After simplifying, P equals 5WL over 4. This load represents the reaction at joint 2. By using equilibrium equation, summation of y equals 0, R1 plus R2 plus R3 equals 2WL, or minus 2WL equals 0. Now we know what is R2. R2 equals 5WL over 4. R1 and R3 are equals because it is symmetry. The structure is symmetry. So 2R1 equals 2WL minus 10WL over 4 over 8. 5WL over 4 is equivalent to 10WL over 8. So this equals to R1 equals 6WL over 8, divide by 2, R1 equals 3WL over 8. R1 and R2 are equals, so we have all reactions. So this solution is the same of the integration solutions, but with less steps. In the next lecture, we'll talk about statically indeterminate structures to the second degree. So this example is for indeterminate structure to the first degree, or indeterminacy equals 1. So the next lecture will talk about structures with more than 1 degree. Thank you.